Baker Atlas presents Pipe Conveyed Logging System Overview. Pipe conveyed logging, commonly referred to as PCL, requires the logging instruments to be mechanically attached to the drill pipe via the latching assembly before being deployed in wells that include high angle or horizontal intervals. To establish the electrical path from the logging instruments to the surface acquisition system, the wireline is run from the surface on the outside of the drill pipe until it reaches the side entry sub, where it is routed inside the drill pipe all the way down to the wet connect inside the latching assembly. This 13-minute animation depicts the sequence of events in a 36-hour PCL operation simulated in a horizontal well of 20,000 feet in length, where an extensive fluid sampling and formation evaluation logging program is executed over the 5,000-foot open hole interval. The several operations performed during a pipe conveyed logging job are listed here and covered in the correct sequence over the rest of this animation. In the following section, the specialized equipment required to perform a pipe conveyed logging job is introduced. Pullback rubber device. This device is used to prevent the wireline from obstructing the iron roughneck at connections while running in and out of the hole after latching. Funnel mud screen. This device prevents solids from getting inside the drill pipe while circulating. Side entry sub. This device provides the path for the wireline to go from outside to the inside of the drill pipe. The clamp, once mounted, prevents pulling on the wireline section inside the pipe after latching. Female wet connect and sinker bar assembly. This assembly includes the wireline cable head, sinker bar, and the female electrical contact sub. Male wet connect and latching assembly. This assembly includes the tool string cable head crossover, latching sub, and the male electrical contact sub. Slotted bush. This device provides a protected slot for the wireline to exit the well to avoid damaging it while running the side entry sub in and out of the hole after latching. Remote tension meter. This device is located next to the tool pusher for him to monitor the compression and tensile forces present at the tool string cable head while running in and out of the hole after latching. We will now review the PCL sequence of operations, starting with the preparation work done at the surface prior to running the logging tools in the hole. Instruments rig up. This tool string includes oil-based mud formation resistivity imager, earth imager, reservoir characterization instrument, straddle packer configuration, cross multipole array acoustalog, high definition induction log, compensated Z-densilog, compensated neutron, digital spectralog, tension temperature mud resistivity, with the tool string hanging from the rig floor, a set of surface tests are then performed. Latch test and tool checks. The engineer verifies the integrity of the tool string, wet connects, wireline, and surface acquisition system prior to running in-hole with the tool string attached to the drill pipe. After these last tests are completed and the female connect taken out of the way, the tool string is attached to the end of the drill pipe and run in-hole to a pre-selected depth referred to as the latching depth. Running in-hole with drill pipe. To maintain the inside of the drill pipe clean of debris, it is necessary to circulate drilling mud at predefined intervals. Inserting mud screen on top of the drill pipe. Circulating mud to clean up debris. Continue running in-hole. Once the tool string is at the selected latching depth, the side entry sub, wireline, and female wet connect assembly are installed. Installing side entry sub. A stabilizer is installed below the side entry sub to protect the wireline while running in and out of the hole after latching. Installing mud screen. Pumping down the female wet connect and sinker bar assembly. Latching and testing. Latch successful. The engineer verifies the electrical integrity of the connection and a predetermined amount of tension is pulled to test the mechanical latch integrity. Removing mud screen. After installing the wireline clamp on the side entry sub, the pipe and wireline are moved simultaneously to run in-hole while logging. Driller's display and hole blockage example. When the tool string hits a blockage, the remote cable head tension meter shows tool string compression, and the driller pulls the pipe back to avoid overcompressing the instruments. To make optimum use of the rig time in pipe conveyed logging jobs, stationary formation pressure and fluid sampling services, along with key primary logs, are performed while running in hole, thus leaving the rest of the logging services for when the pipe and tool string are pulled out of the hole. Logging down to total depth, TD. pulling out of the hole logging. The use of high-performance roller assemblies to stand off the tool string prevents differential sticking, minimizes the effect of friction, and provides a smooth ride. With the logging operation completed, and as the tool string is pulled back to the original latching depth, the side entry sub comes out of the well. Removing side entry sub wireline clamp. Unlatching wet connect. Pulling wireline out of the hole. Removing side entry sub. Pulling out of the hole. While the logging tools are being pulled out of the well, the logging crew clears the rig floor, and the engineer completes any pending data transmissions, performs any required post-acquisition processing, and produces the well site products for delivery. Last, drill pipe stand. Tool string at surface and ready to be rigged down. This tool string includes tension, temperature, mud resistivity, TTRM, digital spectralog, DSL, compensated neutron, CN, compensated Z-densilog, ZDL, high definition induction log, HDIL, cross multipole array acoustalog, XMAC F1. Reservoir Characterization Instrument, RCI, straddle packer configuration, oil-based mud formation resistivity imager, earth imager. This animation provided an overview of the equipment and operations involved in a pipe conveyed logging job as performed by Baker Atlas. For more detailed information, please contact your nearest Baker Atlas representative. Pipe conveyed logging. Thank you for your business.